Title: Using Piezoceramic-Actuated Stage in Precision Long Stroke Motion System, a Design Procedure. The authors are Yazan Al-Rawajdi, Muhammad Al-Saidi, and Muhammad Al-Junaidi. The authors are from Memorial University and University of Ecuador. This paper includes integration of the long stroke of an existing precision motion system with the enhanced short stroke studying the effect of the long stroke motion system and the short stroke motion system by characterizing existing coupling between them, proposing a feed-forward controller that enhances the tracking performance of the piezo-actuated short stroke, enhancing the scanning performance of the dual-stage system under a particular step and scan trajectory. Positioning stage: it is XY planar scanner from physics instrument with a resolution of 1 nanometer. This stage is driven by ACS motion controller. This stage has 3 ironless brushless 3-phase linear motor in each configuration as shown in the figure, where we have 2 motors in the y-axis and 1 motor in the x-axis, air bearing levitation system and anti-vibrating system. The feedback compromise absolute in. The long stroke: it is usually modeled using generic unidirectional multi-mass block model, which can be represented by the following linear model. This linear model has 1 rigid body mode and n-1 flexible mode. This long stroke: it is driven by step and scan trajectory, which is represented by the following acceleration profile. Piezo-actuated short stroke: it is piezoceramic short stroke from Mad City Lab with internal position with a resolution of 0.06 nanometer, and this stage is driven by nano drive amplifier, which provide high voltage of maximum of 150 and collect the position measurement. The characteristic between the output displacement and the applied voltage: it is represented by the following model, and this characteristic and hysteresis loop: it is modeled using rate-dependent branch Riccinski model. The combination between the long stroke and the short stroke: it is given by the following figure. The desired motion profile: it is injected as desired signal, and the motion system used to control the long stroke, and the short stroke: it is driven by nano drive, where the desired is the error in the long stroke. The controller for the short stroke: it is the inverse rate dependent feed-forward controller. Now, the electromagnetic interference. In first, we study the interaction between the long stroke and the short stroke by fully enable the long stroke. As shown in the figure, we have an interference at frequency for the 100 when use aluminium stage between the short stroke and the long stroke, while in the acrylic material for the stage between the short stroke and the long stroke, we see that reduce the electromagnetic interference. Performance: the total positioning error: it is represented by the following equation, and the final error: it is enhanced for the step and scan profile. So we consider the following step and scan profile for the motion in the y direction and x direction. This figure represented the error signal with and without using the enhanced short stroke stage. So we see that integrating the short stroke in the system reduce the error and the total error in the position, which enhance the performance of the system. This figure represented the MA and the MST error.